showcase presentation. So the first company to present is Gaussian Robotics. Daryl Pat will be presenting on how technology increases productivity for facilities management. More efficient and sustainable management of facilities means less wastage of resources, and so this is also considered a green initiative. Daryl is the head of the robotics deployment at Gaussian Robotics, and he takes charge of robotics implementation of various roles across facilities. Daryl also looks at integrating the new FM technologies to aid productivity through innovations such as quality audit software, workforce resource allocation, and IoT sensor technology. Daryl has implemented such solutions across major clients such as Singapore SMRT, Singapore Changi Airport, Marina Bay Sands, Resorts World Sentosa, amongst many others. So please join me to welcome Daryl. Thank you.
Alright, okay, sorry. How am I using my weird? Okay, so good morning. I'm Daryl from Gaussian Robotics. And Gaussian Robotics is together with IFSC. We are proud to present the next generation ecosystem for technology in the facilities management space, FM space. I must caveat up front that it's not going to be very obvious how the suite of technologies I'm about to present to you is going to fit the green and sustainable theme of this event. But I'll summarize right at the end the opportunities that new technologies will bring when it comes to being more eco-friendly. So starting from the top, we have our EcoBot range of robots. They are an integration between man and machine, or that's what we like to think about it. So we think about machines being able to do stuff that are more repetitive and that they can do more consistently and more efficiently compared to a human. And then we need the humans to do stuff that the machines cannot do. The higher value tasks, like cleaning a toilet, for example. Next on its left, we have our RIS Workforce Resource Management Smartwatch for a real way to measure and monitor productivity and in a lean and productive workforce. Okay. Then we have our smart toilets and our smart sensors whether it's in a bin or in a people counter or on a panel on the wall. We use all that to then tell us to change the paradigm of how we clean a toilet, or when to clean a toilet in that sense. And also, these sensors come along with a lot of the AI components where it can predict and help you improve your processes and your workflow to then see when you want to do an activity. Okay, and the last one is we use a quality audit system to remove the need for paper and the exercise of using paper. So we say paper one, we also make it more efficient and make everything more real time. So you don't have to go back and forth and compile and waste human resource doing such things. So very quickly we go into what the EcoBot Scrub 75 is. This is us designing a machine in response to a cleaning industry's requirements. There are many right-on scrubbers in the market, but we really wanted to fix three problems that the cleaning companies continue to face even if they use a right-on scrubber. Right-on scrubbers cannot clean corners, they are very big in size, they take a lot of water, they use a lot of battery, and then we needed something that, if we can create autonomous, should also be able to be used manually. We didn't want a push-behind system, we wanted something that if a old cleaner, which is the typical demographic of a cleaner in Singapore, if they were to use a machine, we wanted them to be able to use it fairly comfortably. So we designed this with those three big requirements, those three big problems we wanted to solve, and then we designed a machine that has now features like the 6-hour operation runtime, water filtration system, the ability to clean edge to edge because of its front-mounted brush head, and in that we'll be able to clean corners. We put in a variety of sensors to test out which is the best at the start, but I realized that the combination of all of them is probably the best idea. They see different things, they are meant for different purposes, and then if we have all of them on the machine on board at one time, we can do more with the machine. Yeah, we wanted to make everything as easy for both the cleaner as well as the person that is doing the initial deployment and the mapping to any location at any one point in time. So I don't know if this will work. Okay, so you'll see on your right, you'll see two videos. I hope they play one after the other. You see them running in operation. Basically, these are the sites we run the machine. The machine is fully autonomous at times. It will move around, it will clean the floor while we're moving around. If it sees people, it will stop. And it prioritizes safety over anything. And this is the top. This is Changi Airport Terminal 3, and this is run video very poor choice of a date. Okay, essentially they gave us a date which was the school holiday or school excursion period. We ran the machine at 10, so at like 9:45 there was nobody there, and then at 10 in the morning there were busloads of human beings, from little children to secondary school students coming out to walk around, and then so that's that. But more importantly, it's about efficiency, right? So when you run a machine, you expect the machine to then, not say replace, but be more efficient than a human. And we have done some of our calculations in math, and every machine will give you a manpower saving of between 0.4 to about 2 headcount per location per run. But to fit the theme, this is where I tell you that the water savings between a traditional machine and our water filtration that we set up means that we are able to save 100 to 300 liters of water per 6-hour run, per 10,000 square meters of give and take. And then this would mean that you could possibly save up to about 9,000 liters of water per month. And this is done through the use of filters. But the use of filters was only meant to give the machine a longer operating time, apart from just battery life. So these are some of the sites we're running at. We've got Changi Airport, Marina Bay Sands, Resorts World Sentosa, NUS, Downtown East, Ocean Financial Center. We can do a range of airports to commercial buildings to retail spaces. And we run this machine also in a couple of different countries. Started off with Australia. Now we have the machine running at Hong Kong, we have it in Korea, we have it in Qatar, and then also Germany. Yep. We clean a lot of airports essentially. Big spaces, perfect for the machine. But then we had a problem. We wanted to clean a smaller space, and we wanted the machine to do more than just be autonomous and still require cleaning. So we worked with a couple of companies and a couple of government initiatives, like JTC, for example. So they wanted something that would integrate into the cleaning workforce more naturally. They wanted, like I said before, the machine to do the consistent, repetitive floor cleaning work, which is, if you use a human, if you use a mop, they would have to try to go in the corners and stuff like that. If you use a right-on scrubber, they will still have to drive it. So a human still has to go on it, have the machine run it. If all that could be replaced by a robot, essentially. We also came up with a new term called minimum human intervention operation. I'll explain that a little bit later. And we wanted to, most importantly, at the end of the day, apart from safety, is to still maintain a very high quality clean. So we designed the Scrub 50, known for its scrub deck size. So this is essentially the 75 has a 75 cm scrub deck. This 50 has a 50 cm scrub deck, and is intended to fulfill this role. If you were to use a human being and a mop and a pail, including the time it takes to refill, you think that to clean 5,000 square meters daily for a month, it will take about 3 hours, 300 hours. And then just to clean, and then 30 hours to do the daily change the water and stuff. If you use a manual scrubber, its efficiency increases by 2, so therefore it moves faster, it cleans a bigger area. But you still need to change water, and throw the water away and stuff like that. Filling water takes time. If you use the robot Scrub 75, well, the machine does most of the work. You still need to put in 15 hours per month to fill in and change the water, change the filters, wash all that. So we decided to build a machine that would not require that. It will be able to charge itself, wash itself, fill its own water, and then, at the best case scenario, take the lift by itself. That's how we integrate the cleaning, and therefore establishing true efficiency. Yeah, like I said, auto charging, auto filling, auto discharging, and this is roughly what it looks like. We still wanted to keep to the same principles. We wanted to be able to clean the corner. We wanted to be able to take up less space but have efficiency. Yeah. And so this is our robot. Yeah. So right now we're running a bunch of tests as a proof of concept. We appeared papers recently in Singapore, and we really only showcased this machine somewhere in CSS about 2 months ago. We have tested it up to being able to cover 1,400 square meters per hour. Battery capacity of lithium-ion batteries can last for about 2 to 3 hours, but water within, probably not so long, depending on how dirty your place is. So it has to go back to the dock, switch out the water, and then come out again. Or we are experimenting with running a filtration system within, so that the water goes through like maybe 1 or 2 filters and then come out. Yeah. And then of course on top of this, now that you have a robot, you can do a bunch of other things that a person may not be so religious in doing. If every time the robot moves, they have a report. Every time the robot moves, it gives you what it covered, what it didn't cover, how long it worked for, and stuff like that. And this metadata is actually very important and very useful for data analysis and to find out there are certain specific areas that your machine or cleaning would be generally difficult. Maybe a crowded space or where there's a built-up area, and if you were to bring out a brown scrubber, it probably can't do its job. If you bring out a human in a mop, it's probably a more efficient method. And then maybe it's a mix and how we integrate that into the cleaning schedule so that some places will be human and some places human cost is high value. Some places we should run with a machine. Okay. So a little bit more of what the machine really looks like. We wanted something also that will integrate directly to the working station. Integrated working station. So those are covered already. You can clean zone by zone, floor by floor. It should work not just as a standalone, but there can be a fleet of it. So think of like the idea of a swarm. You have a mothership and like 5 to 10 will clean your entire compound. And they know if one is down, this other one will cover it, for example. And we wanted to make sure that the maintenance of the machine is fairly simple. So apart from the machine doing most of the own work itself, cleaning the tanks, if you wanted to switch out a part, you wanted to switch out the squeegee or something, or any part is broken, it should be a quick remove and swap type situation. Yeah. So that's all for robots. And then apart from robots, also back to the whole like ecosystem we have, risk workforce resource management. So what this does is really we decided that if you wanted to measure true productivity, you wanted to put something that would be able to measure that, and putting a wearable on a human on a cleaner would probably be the best idea. So that would be the output. That would be the receiver that would then be. It'd be like if you had a phone and your supervisor tell you something, they had to go through a call. But if the wristwatch is the one that would tell you to do something, give you instructions, then it eliminates a human required to do that role. And that role is fairly like, if a supervisor was there to think about who to give the task to, we can run an algorithm that will do the same thing, essentially. Yeah. So for communication, it's for work order management, it's for resource allocations of who to do what based on are you holding the right tools to do something, etc. And improve productivity. Let me see what's supposed to do. Yeah. So essentially, what we wanted to do was to be able to measure 3 main matrices. We want to find out when we give you an order, how long it takes for you to respond to it. You acknowledge it on the watch in 3 simple steps, and then if after you accepted the job, how long it takes for you to start working on it, because you have to walk back, get a particular tool, drive the machine out, and how long it takes you to clean a particular area. And if you can have these data points over time, we can find out if person A does it in 5 minutes and person B does it in half an hour. Is it because person A is better at his job, or person B is more diligent and more like detail oriented? So this will tie in with the last part of our ecosystem, which is the quality audit system that will do the inspection to measure and then provide you some actual matrices that you can compare with. This also is based off the cloud. So essentially you have a workforce of 100 people, they all wear the watch, we know where all them are. We can assign it from afar. You can put in stuff that is periodic, and then we can assign them. And if like suddenly somebody pukes here and you needed somebody to clean it up, you can find out who's the guy that's closest to you, or who has the right tools to do this. Okay, let me just move on quickly. Alright. This also integrates with our other smart sensors. So we've got sensors in the toilet, sensors in the bins, sensors on the panel, sensors that can pick up information whether it's the number of people that enter a toilet, whether it's the number of people that, whether it's the level of smell in the toilet, or even down to whether there's toilet roll in the toilet remaining. And then instead of working on what is, we do two scheduled tasks a day, we clean the toilet 2 times a day, we can work on when the toilet requires cleaning, we will clean. Yeah. So this will again reduce inefficiencies and reduce redundant cleaning. Yeah. Or essentially less people will be required to clean a toilet or toilets. Yeah. So this is just to quickly go through this. The feedback panel. If you were upset about toilet, as a user, if you were upset about the toilet, then you wanted to let us know. You can tell us you're upset, and you can tell us what is wrong in the toilet, and then we can immediately, through the smartwatch again, send a message out to get someone to fix it. Yeah. So similar for smart bins. If the bin is full, we'll empty it, and we only empty bins that are full. We don't empty bins that are not full, essentially. Depending on the kind of sensors you can put in laser sensors, infrared sensors, or ultrasonic sensors. You can probably, with some degree of accuracy, decide if there's water in it, the back neighbors, etc., and then we can fill it up. Okay. The last piece of the puzzle is really the quality of the system. So at the end of the day, any cleaning company or any FM industry will come out and then say, I need to audit how well you have done, a performance indicator of sorts. And right now, a lot of inefficiency is in taking photos and then WhatsApping each other, emailing it, and converting to a PDF and an email and then sending it out. We decided that this is not very efficient, and so we wanted to make it a paperless process where it's more green and at real time. So if you were to take a walk with using the software on the tablet, if you were to take a walk with your client and you walked around and said, oh, this is the toilet and this area is not clean and it's dirty, may not be your fault. It may be not that it's dirty, that it's a cobwebs or whatever. It may be because the mirror is cracked and it's not the cleaning contractor's fault or the FM's fault. Yeah. And then we just need to fix that. And you get this information in real time and it's shared among everybody that needs to know. Yeah, so we use this right now for a bunch of clients. Our biggest client is SMRT, the train service provider in Singapore, and they use it across 105 stations, and it's quite efficient. In the course of a year, we have about 36,000 submissions. It's quite good. So I promise to summarize on what and how technology at the end of the day can still go back to being green and being sustainable. And I think the two biggest components will be this guy. So robots really save a lot of water, and through water filtration. And these guys, they save paper. But the suite of these guys also is just to remove redundancy. So apart from removing redundant headcount or making them more efficient, it's also about going to solve them or fix or clean the area up when it's required. And more and more we're seeing a shift in the paradigm of when we do this and getting building owners also to try and not ask for a scheduled performance base, but a demand performance base. Yeah. So that's all we have for technology, and I'd love to talk to you at the booth if you have any questions. Thank you.